Okay, so for the previous 2 days, we have a very quick review about the quadratic functions as well as their word application problems. And in day 2, we have a review about the translations of different functions. So today, from day 3 to the end of the daily challenge, we will have our review of the geometry part. And for the first day of the geometry part, we have the review about the congruent triangles. Okay, so let's see. The first question is relatively easy, and let's see. We have two right triangles, ABC and the DEF. They are congruent to each other, and we have the angle A equals to 35 degrees, and then we need to know the angle E. Okay, so yeah, since we have the right triangle ABC congruent to the right triangle DEF, we know that the angle A equals to angle EDF equals to 35 degrees. And so we have the angle E equals to 90 degrees minus the angle EDF. Okay, so that equals to 55 degrees, which is choice D. Okay, this one is relatively easy, and people still coming. Yeah, thank you, Ison, for answering the chat box. Okay. So this is how we use the congruent triangles. And let's see another quiet questions. The two triangles shown are congruent, and let's fill in the blank and answer the questions. So we have the triangle TEM. So do pay attention here. We need to have the T to the TEM to the PER, okay? And the angle M equals to the angle R. And TM equals to PR. And ME equals to 1/2. Since ME equals to RE, so it's 1/2 of MR. Yeah. Thank you, Ethan. Okay. So for people coming in, we're at question 2. And first 2 questions just help us have a review about the basic properties of congruent triangles. And then let's move on to see the questions about the isosceles triangles, okay? So as shown the figure in triangle ABC, we have AB equals to AC equals to 39, and AD is the median, and AD equals to 36. Okay. 39, 39, 36. Then what's the length of BC? Okay. So we know that as AB equals to BC, this is an isosceles triangle. And for any isosceles triangle, we have a review, okay? So the following 3 line segments, they coincide. So the altitude AD, and it's also the angle bisector from A to the BC, the base. And also it's the median from the vertex to the midpoint of BC. So D is the midpoint of BC. Okay, so all these 3 line segments, they are just one in this isosceles triangle. And now we have the BD. So since AB equals to AC equals to 39, and we also have the AD equals to 36, And we know that triangle ADB goes to triangle ADC equals to 90 degrees. So we can have the BD equals to CD equals to, so this is a right triangle, which is 30. Okay. Okay, then let's see question 4. As shown in the figure, if the triangle ABC congruent to the triangle CDA, which of the following statements are incorrect? We need to select all the options, okay? So for AC equals to CA, that's totally correct. And for AB equals to BC, is that correct? It's not correct, okay. So since it's not necessary that we can have the AB equals to BC, since we don't know the angle BAC and the angle BCA. So, and for C, we have the angle B equals to angle D, because they're the congruent triangles. And for AC, bisects the angle DAB is not correct, since we don't know if these two angles are equal to each other, but we do have the DAC equals to the angle BCA, okay? So for this two, and for this two, they're equal to each other, but not necessary that AC bisects the angle DAB. Okay. So B and D for this one. Okay. Given that angle M equals to angle A and NC equals to BC, prove that MC equals to 1/2 of AM. Okay. So still remember the different ways, the different theorems that we can prove the congruent triangles. So here we use the AAS. Okay. So AAS is that we have the NMC equals to BAC, and we have NCM equals to BCA, and we also have NC equals to BC. So we can have the triangle NMC congruent to the triangle BAC. So we can have CM equals to CA. And so MC equals to 1/2 of AM. Okay, so this is the application of AAS theorem here. Okay. Then let's see question 6. In the figure below, given that GH perpendicular to HJ, KJ perpendicular to HJ, so both these two triangles are right triangles, and we have GH equals to KJ. So we need to prove that GHX congruent to the triangle KJX. Okay, so first, as we have GH perpendicular to HJ and KJ perpendicular to HJ, so we can have the angle GHJ equals to the angle KJH equals to 90 degrees. And also we have the GH equals to KJ and HJ equals to JH. So we can prove that by SAS, we can have the GHJ congruent to the triangle KJH by SA S. And therefore, we can have the angle GXH equals to the angle KXJ, and we can have the angle G equals to angle K, and we have GH equals to KJ. So by AAS, we can prove that the triangle GHX congruent to the triangle KJX. Okay. Okay, so here we review about the SAS and the AAS to prove the congruent triangles. Okay, let's see the next question. In the figure below, we have AC equals to BD and AD equals to BC. AD and BC intersect at O, and we have OE perpendicular to AB at point E. We need to prove that AE equals to BE. Okay, so first we have AC equals to BD, and we have AD equals to BC, and we also have AB equals to BA. So this is SSS. By SSS, we can prove that triangle ABC is congruent to triangle BAD. Okay, and thus we can have the angle ABC equals to the angle BAD. Okay, so this is isosceles triangle. We can prove that AO equals to BO. Triangle AOB is an isosceles triangle. And as we have the OE perpendicular to AB, we know that this is also OE bisects AOB and E is the midpoint. So that's the basic properties of the isosceles triangle. Therefore, we can have AE equals to B. Okay, another question help us review about the basic properties of the isosceles triangle. Okay, any questions so far? Okay, then let's see the last question. Okay. So as shown in the figure below, in the triangle ABC, we have DE equals to EF equals to FD, and we have DE perpendicular to BC, EF perpendicular to AC, and FD perpendicular to AB. So the side lengths of the triangle ABC is 3. So AB equals to BC equals to CA equals to 3. We need to find, so here it's not triangle ABC, okay? I corrected it into triangle DEF. So let's see. Since we have DE equals to EF equals to FD, we can have the DEF equals to EFD equals to FDE equals to 60 degrees. And also, as we have DE perpendicular to BC, EF perpendicular to AC, FD perpendicular to AB, we can have angle DEB equals to angle EFC equals to angle FDA equals to 90 degrees. And therefore, we can have the CEF equals to BDE equals to angle AFD equals to 30 degrees. Okay, and now based on the ASA, it's easy to prove that the triangle DEB congruent to the triangle EFC congruent to the triangle FDA. Okay, so we have 6 degrees, 30 degrees, 30 degrees. Okay, and now we know that in a right triangle with the two other angles as 30 degrees and 60 degrees, the ratio between DB and BE equals to like EC, CF equals to the ratio of EA and AD. They're all 2/1, okay? So we can have, so since we have AB equals to BC equals to CA equals to 3, so that's we have the DB equals to EC equals to FA equals to 2, and we have BE equals to CF equals to AD equals 1. And then we can know that DE is √3. And it equals to EF and DF. Okay, so DF, we also can have a perpendicular line here. So let's say it's G, okay? So EG would be 1/2 of the DE. And we can have the DG equals to 3/2. So for the area of the triangle DEF, it equals to 1/2 times √3 times 3/2, which is the height. So that's how we get 3√3/4 as the final area for the DEF. Okay. Okay, time for notes. So for all the 8 questions, we cover from the very basic ways to prove the congruent triangles, and then we move on to the isosceles triangles, the basic properties of it, and then we apply the basic properties to solve some like area solving questions. So that's for the congruent triangles. Okay, guys. Okay, no questions. That's for today, and see you tomorrow. Okay. Yeah, you're very welcome, Ethan. Thank you for joining. Bye, guys.